Dear students, today we will learn about the Newton-Raphson method to solve f of x equal to 0, where f of x is a non-linear function. So what are the major steps? This method is very important with the every examination point of view. So listen carefully each and every step. What is Newton-Raphson method to solve f of x equal to 0? You will be given f of x, a function will be given to you people, and you need to find the derivative of that function f of x, which is actually f prime x. So you need to calculate f prime x and replace x by xn in both f of x and f prime x. Secondly, initial value x naught will be given to you people. The starting value or the interval in which the solution of this equation lies, will be given to you people. If these two, if the initial guess or the interval is not given to you people, then what do? You need to put x equal to 0, 1, 2 and so on in the function, in the given function. So replace x by 0, then x by 1, then x by 2 and so on in the given function, and note down the change of sign in the value of f of x, the change of sign. So if f of x changes its sign for any two consecutive values of x, remember that consecutive value of x, the interval will be that one and the small value of the interval will be x naught. Now the most important one is to use the Newton-Raphson formula to find the different iterations with the help of Newton-Raphson formula, and that is Newton-Raphson formula. You need to replace f of xn, f prime xn in this formula, and again put n is equal to 0 to get x1, then n is equal to 1 to get x2, then n is equal to 2 to get x3, then n is equal to 3 to get x4 and so on. We will start the iteration process as we have learned previously in the simple iterative method, that we will start the iteration process if the two consecutive values of x are equal to the required accuracy. What does it mean, the required accuracy? It means that if you want to find the solution up to 4 decimal places, then you need to check whether the two consecutive values of x obtained from Newton-Raphson formula are equal to each other up to 4 decimal places or not. If you are dealing with 5 decimal places, then two consecutive values of x must be equal to up to 5 decimal places. So that is actually Newton-Raphson method to solve f of x equal to 0. The method is very important and also very simple to understand. Let us try to solve an example. The example is find the real root of this function x square minus 2x minus 2, correct to 3 decimal places. Remember that. So we need to find the root of this equation up to 3 decimal places by using Newton-Raphson method, and it also given to you people that x naught is equal to 2. Anyways, let us start the solution. The function is given to us x square minus 2x minus 2, that is the function. We need to find the derivative of this function. So find the derivative of this function. The derivative of x square is 2x and the derivative of 2x is 2 and derivative of 2 is 0. So f prime x is 2x minus 2. Now we need to replace x by xn in both f of x and f prime x. So whenever you replace x by xn here, you'll get this thing, and whenever you replace x by xn here, you'll get this thing. So these two. Now for initial guess is given to us, x naught is equal to 2. For example, if this initial guess is not given to you people, then we will try this step. We will try to put x equal to 0, 1, 2, 3 if this is not given to you. So let us put x equal to 0, 1, 2, 3 and f of x, and this f of x. So whenever we put x equal to 0 here, we will get f of 0 is equal to minus 2. Whenever we put x equal to 1, we will get f of 1 is equal to 1. So we see that f of x changes its sign. F of x changes its sign minus 2 and plus 1. For x equal to 0, the function has negative sign, and for x equal to 1, the function has positive sign. So as f of x changes its sign for x equal to 0 and x equal to 1, so therefore interval is 0 comma 1, and this initial value of this interval, the small value of interval, is actually x naught. So this x naught is actually 0, not 2, but this is 0. Correct this thing. For example, if this is given to you that x naught is equal to 0, so there is no need to perform these steps, because we are in search of x naught, and that is already given to you people. This x naught is equal to 2 is wrong, so correct this 2, that x naught is equal to what? 0. Remember again, if this initial guess is given to you people, so there will be no need to perform these steps. There is no need. And if this initial guess is given to you people, is not given to you people, then we need to perform these steps to find the value of x naught. So that is for initial guess actually. Now we need to use Newton-Raphson formula. Newton-Raphson formula is this one: xn plus 1 is equal to xn minus f of xn divided by f prime xn. But f of xn is this one, and f prime xn is this one. So xn plus 1 is equal to this whole value. This is xn plus 1. We need to put n is equal to 0 and this equation. Whenever n is equal to 0, from left hand side we will get x1, so that is x1, and on right hand side we will get x naught. All these will become x naught, so they are x naught here, x naught. But we know that x naught is equal to 0, so replacing x naught by 0 here, these three values, and calculating this fraction, we will get minus 1. So x1 is equal to minus 1. That is the same criteria as discussed in the simple iterative method. Now replacing n is equal to 1 in this equation in Newton-Raphson formula, whenever you replace n by 1, we will get on left hand side x2, so that is x2, and on right hand side all these xn will become x1, so these are x1. But we have calculated the value of x1 as minus 1, so replacing x1 by minus 1 in these three portions and calculate this fraction, we will get minus 0.75. Now similarly, whenever n is equal to 2, so on left hand side we will get x3, and on right hand side we will get x2. All these three will be x2, but x2 is minus 0.75, so replace x2 by minus 0.75, we will get this answer. Now we see that these two answers are equal to each other up to 1 decimal place, but we are going to find the solution up to 3 decimal places. So again we need to put n is equal to 3. Whenever we put n is equal to 3 in this equation, we will get x4 on this side and x3 on that side, but x3 is actually minus 0.732. So replacing x2 by minus 0.732, we will get this answer. Now we see that this answer, these two consecutive values of x are equal to each other up to 3 decimal places. So the values of x3 and x4 are equal to up to 3 decimal places, so the required root is the same, minus 0.732. so that is actually Newton-Raphson method, and very simple to understand. And now how could we find the solution with the help of a calculator? So let us try to use calculator to find the different iterations in Newton-Raphson method. Now this is the calculator. We just need to put this equation in the display of the calculator. Denote this thing by y, or whatever you want this thing by y. So that is y is equal to, then all these xn's are denoted by x. So x minus x square minus 2x minus 2 by 2x minus 2. So right here x minus x square minus 2x minus 2, that is in the numerator. Now in the denominator we will put 2x minus 2, so that is 2x minus 2. So we have written this equation in the display of this calculator. We just need to press this calc button. It will ask you about the value of x. Because we are dealing with the numerical solution up to 3 decimal places, so fix your calculator up to 3 decimal places, and that will be just like shift setup 6 up to 3 decimal places. Now your calculator is now up to 3 decimal places. Now what is the value of x? The initial value of x is x naught, and x naught is 0. So put x naught is 0 is equal to minus 1.000. Just look at that, minus 1.000. Now again equal, then answer, then equal minus 3.4 minus 0.750. Just look at this thing. Again equal, answer 0, and that is minus 0.732. Again equal, answer, equal, and this is minus 0.732. So you see these two values are equal to each other up to 3 decimal places, so the required root is this thing. So this is how we use calculator to deal with the Newton-Raphson technique.